In this lesson, we are going to graph and solve absolute value inequalities. So we've done equations, now we're going to work on inequalities. So remember in our graphing, if f of x is greater than, we shade above. If it's less than, we shade below. Now greater than and less than are dotted lines. They're open circles, not included. If it's greater than or equal to, or less than or equal to, those are solid lines, closed circles. So let's see how we're going to graph these and shade them. So remember our regular parent function for absolute value looks like this. It's our v, and this has a slope of 1, 1, 1, 1, 1. So anything other than 1, 1, that's our vertical stretch or compression. So let's start with the first one. It says f of x is greater than 2 absolute value x minus 2. So I know my normal graph starts at 0, 0. This one's going down 2, and it also has a vertical stretch by 2. There's that a value, so that's going to make it stretch. It's going to make it more narrow. So let's start off by going down 2. 1, 2. Now, if it didn't have this vertical stretch on it, I would just do a slope of 1. Go 1, 1, 1, 1. But since it has a vertical stretch of 2, I'm going to go up 2 and over 1. So up 2 over 1, up 2 over 1. I'll do the same thing on the other side, except I'll go up 2 to the left 1 because I'm trying to make my V shape. Notice it says greater than, so it is not a solid line, it's a dotted line. So there we go, another dotted line here. Now greater than means we shade above. So my choices are shade inside the V or outside the V. Well, outside the V is considered below, so I'm going to shade above. And there's my answer. So my graph with the dotted lines, with the right transformations, and then the correct shading. So I have a couple of questions over here. Is 0, 0 part of the solution, or is it part of the problem? So if I look on the graph, 0, 0 is inside this shaded area, so I'm going to say yes, it's part of the solution. Is negative 4, 0 a solution? Well, let's find negative 4, 0 on the graph. That is out here in the non-shaded area, so it's not a solution. Is 2, 2 part of the solution? Well, let's see. 2, 2. Well, there's a dot on the line, but it's a dotted line. Remember we said the dotted line was not included? So 2, 2 is not included as part of the solution. If I plug it in here, I would get equal to, but it doesn't say equal to, it just says greater than. All right, let's graph another one. Oh, we have a couple of notes here. Everything in the shaded region is part of the solution. Everything on the dotted line is not part of the solution. Everything on a solid line would be part of the solution. So anything that's shaded is part of the answer. If it's on a solid line, it's the answer. If it's on a dotted line, it is not part of the answer. All right, next one. So let's talk about the transformations this time. I have a vertical stretch by 2. That's going to be my slope. X minus 4, that went to the right 4. And that plus 3 goes up 3. So anything inside with the x is horizontal and it's opposite. So instead of starting at 0, 0, I'm going to start at 4, 3. That's going to be what we call the vertex. From there, we're going to count our slope of 2. So from here, I'm going to go up 2 over 1. Up 2 over 1. Now this was less than or equal to, so I'll do a solid line this time. And this one says less than or equal to. So shading inside the V was greater than, so I'm going to shade everything on the outside. So is 0, 0 part of the solution? Is it shaded? Yes. Is 4, 3 part of the solution? Well, that's a point on the solid line. So remember, the solid line is part of the solution. Is 4, 5 a solution? 4, 5. Well, that's inside the part that's not shaded. So no, that's not a solution. That's how that works. All right. Now let's graph this one. -2, absolute value of x. So first off, notice it's a reflection over the x-axis, and it's a vertical stretch by 2. So the negative tells me to reflect it. And remember, we took the absolute value to find out that 2 was a stretch. If you look at your notes, it says if the absolute value of a is greater than 1, it's a stretch, and that's what it is. So it didn't translate up, down, right, left. It stays at 0, 0. Now the slope is still a 2, but it's pointing down this time. So I'm going to go down 2 over 1 to get my V shape. It says equal to, so I can do a solid line. And there we go. Now it says greater than or equal to. So let's think about it. Inside would be the less than side. Greater than would be all of this out here. And that would be my graph. So we're looking for, did you do the correct reflection? Did you do the correct vertical stretch? And did you shade the right area? Let's do the next one. This one, it looks like the same graph, -2 absolute x. So I'm just going to graph the same thing. 1, 2, 1, 2. And it says equal to, so I'm going to do a solid. But this one says f of x is less than or equal to. So this one said greater than. So greater than, I shaded above. Less than, I'm going to shade below. So it's everything inside the V this time. All right. Okay, next page. So we're going to solve our inequalities in a very similar way as we did the equations. We're going to write 2 separate equations, and we're going to do this. The first equation looks exactly like the original problem. X plus 2 is less than 6. Your second equation, it's still going to say x plus 2. We're going to flip the sign and make it negative. Okay, so the first one stayed the same. Remember, in equations, we just said x plus 2 equals -6. Well, we still do that, but we also flip the sign, so be careful. So when I subtract 2, I get x is less than 4. And when I subtract 2, I get x is greater than -8. Now I'm going to put these on my graph, and we'll take a look at them. So you don't have to label every single number. We just know there's a -8 and a 4 that I'm worried about. So I want to be less than 4, so that goes this way. Well, then I want to be greater than -8, so that goes this way. Well, in order to do both of those things, my answer is just going to be an open circle at -8, an open circle at 4, and everything in between. So this particular one says x is less than 4 and x is greater than -8. Could I write that like we did earlier this year, where we just put -8 is less than x is less than 4, just to say x is between -8 and 4. So you could write it either way. But because it said less than, that's an and. So it's in between the two. It's bigger than -8 and less than 4. So we've narrowed it down to those numbers. All right, let's try this one. So this one, we have to isolate our absolute value before we start to solve, just like we did last lesson. So if I divide by -4, I divided both sides by a negative. We talked about this earlier. Here's another note. If you multiply or divide both sides by a negative, you flip the inequality. That is a huge thing to remember. It only happens if you multiply or divide both sides by a negative, which is what we're doing here. So it stays absolute value of x minus 3, and we're going to change it to greater than -12 divided by -4 is 3. And now we write our two separate equations and we solve. So I have x minus 3 is greater than 3, and then I'll have x minus 3, flip the sign, -3. So that same rule. The first one looks exactly like this without the bars, and the second one we flip the sign and make it negative. So adding 3 to both sides, x is greater than 6. Adding 3 to both sides, x is less than 0. So let's see what that looks like when I put it on a number line. Again, you don't need every point in between. We just need the 0 and the 6. So for x is greater than 6, that's an open circle to the right. X is less than 0, that's a closed circle to the left. Now remember when we learned these, if there was a gap in between, we put an or. So for less than, we put an and, but right here for greater, or for this particular problem, I say greater, it's an or. So less than got the and, the in between. Greater gets the or because it goes different directions, and that's an or for the gap in between. All right, let's do the next one. This one, so we need to get rid of this 4 that's not in the absolute value bars, and because it says 4 plus absolute value, we're not going to divide by 4, we're going to subtract 4. So I get absolute 2x plus 4 is greater than or equal to 4. Let's write our two separate inequalities and solve them. The first one, you copy the exact same problem without the bars. The second one, 2x plus 4, change the sign, -4. Be really careful there. All right, so subtract 4 from both sides. 0. And if I divide 0 divided by 2, I just get 0. This one, I'm going to subtract 4 from both sides and get -8. And when I divide both sides by 2, I get -4. Now, this was a greater. So remember greater. There's an or. And that's going to be evident when we graph it. Let's see. I have -4 and 0. So if I go greater than or equal to 0, close circle to the right, less than or equal to -4, close circle to the left. So that when you see the graph, you're like, oh, that's an or, because it's this way or it's that way. It can't be both at the same time. All right, the next one. So once again, the -3 is not in the bars, so we're going to add 3 to both sides. So I get absolute 2x minus 5 is less than or equal to 17. Now I write my two inequalities. The first one is identical to this without the bars. The second one, you still keep 2x minus 5, flip the sign, and make it negative. And now we solve. Add 5 to both sides. 2x is less than or equal to 22. Divide by 2. X is less than or equal to 11. Other problem. Add 5 to both sides. -17 plus 5 is -12. Divide both sides by 2. X is greater than or equal to -6. Now back here, notice this was a less than. So this is going to be an and. When you graph it, you'll see that. So I've got a -6 and an 11. For x to be greater than or equal to -6, that's a closed circle and an arrow to the right. To be less than or equal to 11, that's a closed circle and an arrow to the left. So in order to do both of those things, that's just closed circle with everything in between. I'll highlight that so you can see it better. But that's your answer. So I did the one on top just so I could see how it goes this way and this way. So remember, if you wanted to, once you see this, you could say that -6 is less than or equal to x is less than 11. It's in between. So you could write either of those answers, and that would be correct. So we're less than 11 and greater than -6. Those are the numbers. Or you could do this notation to show that it's in between. So be really careful with your inequalities. Remember, when you write your second one, you flip it and change the sign. And also remember, oh my goodness gracious. If you multiply or divide both sides by a negative, you flip the inequality.